Hi everyone. So often in this class I get questions about how do I pick good windows when I'm trying to graph something on the graphing calculator. And so many people get frustrated with not knowing, where to start with picking windows and kind of feeling like they're just guessing. So here's a quick little tip that's going to help you so much when you're trying to graph, especially a quadratic, to do before you go on the graphing calculator. So if I were doing this is just an example of an object being thrown up into the air with some initial height and some velocity. And let's say you were trying to get a picture of it. So if I go on the graphing calculator right now, I probably have no idea how long this object's going to be in motion, how long it's going to take to get to the ground, where its highest point is. So I have no idea how to pick appropriate windows, and I'd be just guessing. So the quick tip that I'm going to tell you to do before you go onto the graphing calculator is to do a little bit of work, and this will help you so much. If you just, by hand, which is easy enough to do, if you find the vertex first, that will tell you a whole lot about the path of this object in this quadratic. So let's find our x part of our vertex using our opposite of b over 2a. So that's going to give us a negative 160 over 2 times negative 16. So the x part of our vertex is going to come out to be a positive 5. So that means after 5 seconds, this would be time. After 5 seconds, that's when it's reaching its highest. We're going to sketch it out in a second. But let's find the rest of it. So let's do the y part of our vertex. So that is really finding h of 5. Okay, so let me put this in here. So it's going to be negative 16, 5 to the second, plus 160 times 5, plus 32. And that's going to end up coming out to be a 432. So this one was in, I know I didn't say at the beginning, but this was in feet. So that's our highest point. After 5 seconds, this object reaches a max height of 432. So you really just found out so much about this quadratic, and now you know good windows. So rather than go on the graphing calculator, I'm just going to sketch and talk about what windows we would pick. So let's see what would make sense for our x min, our x max, y min, and our y max in this case. Okay, so we just said, let me sketch down here what we have. Whoops. So we've got this, I'm going to draw an L-shaped graph. For this particular one, that's the only quadrant that makes sense for this. And let's see, what else do we know? All right, so we know that it is starting at a height of 32. We know it's going up and coming back down. This is just a little bit of a sketch to get us picking good windows. And we just figured out that after 5 seconds, the height of it is 432 feet. So right there, if you look at this, we know good windows. So let's start with the y. So our y min doesn't have to go below 0. Look at our little sketch there. Our y max has to just go maybe a little over 432 just so we can see the whole shape of it. So I would just say maybe 450. And our x min, okay, we know time's not going to go below 0. And our x max, we're not quite sure where it is, but that's okay. We know we don't have to go out to like 100. A lot of times what people end up doing is when they don't see what they want to see, they just make their windows really, really big. And that's sometimes the worst thing that you can do. So like me going out on the x-axis to 100 would make this look so squished up. If we know it reaches its highest after 5 seconds, if you double that and go a little bit more, you'll see what you need to see. And so that's how you can pick really good windows. And all I really did to do that was find the vertex. The vertex told me roughly where the highest point is and how long it's going to take to come back and hit the ground all the things I needed to pick good windows. So when you're trying to do these this week and you're trying to graph them on the calculator, try that first and it will help you so much.